Right, recording has been started. Camera isn't the best today. Neither is the location. Sorry for the lighting. Let me share my screen at any time. If you feel the internet is not good, just spam hand raises and I would know. And what we'll be doing today is a bunch of this. The things that have checkboxes right next to it, we'll be trying to do today. What doesn't have checkboxes, we'll most probably be doing tomorrow. We most probably have to do ASGs also tomorrow, or the implementation of ASGs. What is an ASG? An auto scaling group. This probably will be done tomorrow because my AWS account has limitations as to how many machines I can create. And I've sort of used it to peak. I've requested for an increased limit. I don't think it has happened right now. So we'll have to do this tomorrow. And most probably these two also will be doing tomorrow. The rest we'll try to cover today. Where can you find the slides? You can find the slides at the end of projects.100xdevs.com. In this section called horizontal and vertical scaling, indexing in databases. That is what we'll cover this week. Basically some advanced concepts in scaling, some more advanced concepts in databases. We'll also cover a little bit of Rust to show how it's, better than Node.js. Specifically, when you want to scale, what makes it. So Rust is 10 different things, like it's memory safe, it's faster, but what makes it scalable? Node.js is very inferior when it comes to a comparison with languages like Java, Rust, Golang, because these can spin off multiple threads. They are multi-threaded. What is Node.js or JavaScript? Single-threaded. So we'll try to do some coding and implementation and try to see whether the other languages are better. We'll understand about the cluster module that pretty much lets Node.js get close to the capabilities of Golang or Rust. Let's say not very close. Like there is a difference between multi-threading, the way it is done in Golang and Rust, and the way we'll be hacking it on today. And one way to hack away, using multiple threads in JavaScript is using the cluster module. So we'll spend some time there. We'll understand what is horizontal scaling. Then we'll understand what is vertical scaling. These should actually be flipped. Vertical scaling should come here, horizontal scaling should come here, and auto scaling groups, which let you horizontally scale on AWS. Most clouds will have some construct to let you create auto scaling groups. What does auto scaling groups mean? Means a bunch of servers that you can describe. KR, if the CPU usage goes above 50%, please increase the number of servers, auto scale up. And then if the CPU usage goes very low, like 10%, then auto scale down. We'll talk a bit about capacity estimation, which is, just a buzzword and a system design question. A lot of times they will ask you, okay, estimate the number of videos that are uploaded to YouTube every day. How do you do that? Mental math. Load balancers, probably not today. When we understand ASGs, is that we understand load balancers and a bunch of other constructs that are used to create an auto scaling group. Indexing we'll cover today. Normalization and sharding we'll cover tomorrow. Yeah, that's pretty much it. The interesting bits here, I would say, are, probably this ASGs and normalization. Everything else should be fairly straightforward. Cool. That's enough context for today. Let's get into it. Let's kick things off by understanding vertical scaling. I actually want to start with a poll. Okay, how many of you already understand this? But either via first principles or you've heard of it. Do you know what horizontal and vertical scaling is generally? Most of us do. No, most of us don't. Sorry. 50-ish. Okay, so half of us know, half of us don't know. It's very obvious once you think about it. What does vertical scaling mean? Maybe even before that, why do you need scaling? If your application gets a lot of load, then you need to scale up. It's not necessary that your application, look at that. This is what we'll be covering today. If this is your, AWS machine, easy to machine, where you're running a Node.js process, let's say node index.js. This can be used by a lot of people, not just one. Do you think an application like Swiggy is used by only 10 people? No, it's used by millions of people. So you need to somehow make this process very powerful. You need to say, take as many resources as you want. Here, take, more CPUs and more, let's say, theoretically GPUs or more memory, whatever you need, more file system. I will give you as many resources as you want so you can handle these requests. When you increase the size of an EC2 machine to do this, when you move from, a C5.x large machine to C5.4x large machine, What does this transition mean? What is C5X large? It's just a machine type in AWS. If you're ever in AWS, if you're ever in AWS and try to create an EC2 instance, it asks you, what is the size of the machine you need? The bigger the size, the more that you have to pay. So if you're scaling this way, if you're like, yeah, I'm going to expect a lot of load, let me increase my size to be not micro, but the biggest machine that exists over here. Let's say C5A metal, which is $4 per hour. How much is that in a day? 24 into 4, like $150 a day, which is how much? $4,500 a month. If the math is right, somewhere in that range, right? 3-4 lakh rupees a month. If you feel like, yeah, we are going to have a lot of load. Swiggy doesn't care. If an application like Swiggy is making millions, why would they care if getting a big machine helps them handle the load? So this is what vertical scaling means, because you're vertically increasing the size of the same machine. If this was your machine first, it only had one CPU. Now it has 20 CPUs. If only had 8 GB RAM, now it has 32 GB RAMs. So you're vertically scaling a machine and trying to you're hoping that your Node.js process will, be able to handle more requests if you vertically scale a machine. But do you think that is possible? Do you think that is necessary? Okay, if you vertically scale a machine, if you keep adding resources to the same machine, the Node.js process is able to handle more requests. What do you think the answer is? Do you think it is possible for your Node.js process to handle more load if you vertically scale your machine? And 50% say yes, 50% say no. The answer is no. You can say yes, something might happen, it might have more memory. If the Node.js process uses a lot of memory, then sure, increasing the size from 8 GB memory to so much memory might help the Node.js process. But specifically for processing, specifically for running for loops, if there is an expensive operation here that's happening, that's being handled over here, where does all of this run? This runs on a CPU, central processing unit. And what did we keep saying again and again? We said JavaScript is single threaded. What does being single threaded mean? It means it can only utilize one of these CPUs. It does not matter how much you scale your machine. You could have 4 vCPUs, you could have 8, 16, 32, 64. There is no point of making your machine beefier and beefier if all you are doing on that machine is running a node process. Node cannot take the benefit of all of these CPUs. It will still run on a single CPU only, irrespective of how big you make your machine. So Kirat, should I just go with a very small machine then? Yes, unless it's going to use a lot of memory. The only problem that might come in a very small machine is, some build process is not able to happen because the CPU is not, you need like more than one threads for it. What do you mean by build? Converting, JSX to JavaScript. If you compile your React project, a lot of times on, a T2.micro machine, which a lot of you might be using if you are using the, free tier over here. The T2.micro runs on, it says free tier eligible. So we've recommended again and again, if you're starting a machine, please start it here. Running the Node.js process here is fine. It only has one vCPU. Doesn't matter if it has one or if a different machine has, 32. That is fine. They will still perform similar, not exactly the same, but very similar. It won't linearly grow for sure. If there is one CPU and you make it 32 times bigger, you are paying 32 times more money, doesn't mean you get 32 times the performance. You might get 1.1 times the performance. Something extra you might be able to squeeze out here and there in a bigger machine, but not linearly. The downside is that some build process might not be able to build over here. Your machine might run out of CPU memory. I cannot build your React project. But if it's a single Node.js process, then just throw it on a micro machine, a mini machine, it'll work. Then the question is there any point of doing vertical scaling in a Node.js process? Vertical scaling means increasing the size of your machine to support more load. What does increasing the size mean? Doesn't necessarily mean increasing the hard drive. It means increasing the memory. It means increasing the number of CPUs you have. For example, if this is a Node.js machine and this is my Mac machine, this is a Node.js file which I run by running node-index.js. It doesn't matter how many vCPUs I have. My current Mac, I have 10 vCPUs, but my Node.js process will run on a single one. Does not matter how much load it's getting. Does not matter, what optimizations I do here. it can only be handled by a single processor or a single CPU, because it's single threaded in nature. It has a single thread that's going into an async function, an express handler, wherever it's going. There's no way to parallelize this. You can't really split it. You do this part, you do this part, you do it on thread 1, you do it on thread 2. You cannot parallelize, which means Node.js, not the most effective way to scale it is vertical scaling. You can try, but you will see diminishing effects. After a point, you will see no effects. So if you have a Node.js process, no point renting a very beefy machine, rent a small machine, you'll get the same performance. This is in stark difference to multi-threaded languages that do let you use all the cores of your machine. What are good examples of these languages? Java, Golang, Rust. If you have done Java, you might have created a thread pool over there. If you've done Rust, you might have spawned threads over there. If you've done Go, you might have heard of something called subroutines that let you create small routines that can be run on different threads. What do all three of these let you do? They let you parallelize. They let you be like, you run here, you do this task, you do this task, you do this task, so on and so forth. And why is this useful? This is useful because if you have a beefy machine, why do you want to keep so many cores idle? Why do you want Rust, you only run over here? I will only give you, 1/10 the power that exists on this machine. You don't want that. And hence, you can write code in a way. You have to write code in a way. It's not as easy as, I will create a for loop and it will get parallelized to all of these cores. No. If I give you a problem statement that says, find me the sum of all the numbers from 1 to let's say 1 million or some big number like this, and you write a for loop. Okay, I will do this for let I equal to 0, I less than very big number, I plus plus, answer equal to answer plus I, and then console.log answer. If you do this, or if you write similar code in Rust, Golang or Java, all of them will be able to compute this on a single thread only. Right? Writing multi-threaded code isn't as easy as I will write this code and then the CPU will itself parallelize. No. If you want to write the optimal version of this in Java, in Golang, in Rust, you will have to write it somewhere like this. I need to find the sum from 1 to 1 million. I will split this into a bunch of 10 chunks, let's say. 1 to whatever this is, 10 is per 8, and then 10 is per 8 to 2 into 10 is per 8, and then 2 into 10 is per 8 to 3 into 10 is per 8, so on and so forth. You will create a bunch of chunks. This is the first 10% of the sum that I need to find. This is the next 10% of the sum that I need to find. This is the next 10%. And you will write code that looks something like this. For slice in, slices, let's say we store these in like a bunch of slices. You will do a thread.spawn, some function over here, which will actually find the sum for that. Run a for loop to find the sum. And then eventually you will aggregate the results from all 10 of the cores and be like return, answer 1 plus answer 2 plus so on and so forth. So it's slightly difficult to write multi-threaded code. You can't just assume I write a for loop in Golang and it will be extremely fast. It will run on multiple threads. No. You have to write code as an app. As a developer, it's your responsibility to, write this code to spawn threads, to tell the compiler of Golang, of Rust, please break this job down into 10 parts and individually do these on 10 different threads and eventually accumulate them into a answer variable. How would you do a daily task? Let's say if you have to do 3 things today, if you have to, eat breakfast, get some medicine and go to the beach. Maybe not go to get medicine and get food. You can either do all 3 of these together yourself. So sequentially, I will do 1, then 2, then 3, or you can parallelize. I will do one thing, you do the other thing, you do the other thing. And when the results are there, I will just join the results and all 3 of my tasks are done parallelly. That is what this code on the right would let you do in a language like Rust, Java, Golang. So the question is, Harkirat, there is no point of vertically scaling a Node.js process. You are saying, it works for these guys, and For these guys also, it only works if you write code like this. I can't write a for loop and assume it will run on multiple cores. I have to tell the compiler, okay, hey, please spawn a new thread that does this, spawn a new thread that does this. And here I will, of course, find the sum from, for the first iteration, I'll find the sum from 0 to 10 raised per 8. For the second iteration, I'll find the sum from 10 raised per 8 to 2 into 10 raised per 8. But they're happening on separate threads. They're happening on separate cores. They are parallelly doing the results, and then you're accumulating it eventually. Can we see this in action, Harkirat? Can you show me, okay, this, whatever you're saying actually happens? Sure. Let's create an infinite while loop. And let's try to run this locally on, whatever machine you might have. You might have to install htop if you want to see stats like these, like I see on my machine. You can also run top and you'll see some, but either way, you need some way to monitor. Or you can also open, if you're on a Windows machine, which I've seen a lot of people are, you can open your system analyzer and look at the CPU usage. Either way, let's try to create not just a for loop that finds the sum for a very big number. Let's create an infinite for loop. Okay, keep on running forever and ever. Let's copy this code. Very simple. Let c equal to 0, initialize a variable, and then an infinite while loop that keeps on running the same thing again and again, never stops. This should keep the CPU very busy. Ideally, you would want, if I am on a 10 core machine, this should parallelize. This heavy task of increasing C should be parallelized on various threads or various cores. But does that happen? Let's see. Let's copy this code. Let's open a random variable, a random folder. And since I don't need any dependencies, I'm just going to open it here, vindex.js, and paste it. You can open a file in Visual Studio Code, in Notepad, wherever, and paste it. I'll wait for 10-15 seconds in case you want to try it locally as well. What have I done? I've just created an index.js file where I've put the contents that were present here on the website, which is defining a variable and then running it in an infinite for loop. 10 more seconds and then I will proceed. I've used Vim, feel free to use Visual Studio Code and open the file and run it. Let me just open it in Visual. I actually cannot. You get the idea. It's fairly simple. Just open the file and then run the file. Node index.js. What is this doing? Infinitely running a for loop that's trying to compute something. Of course, it's computing a very useless thing, but it's trying to compute something. How many cores of my machine do you think are running? If all of my cores of my machine were doing this, the Zoom call would have stopped. The Zoom call would have at least fumbled a bit. Okay, sorry, we have a very expensive operation. If I open GTA on a very own laptop of mine, then of course the laptop will begin to struggle a bit, right? I cannot open Zoom in that laptop. So if this was actually multi-threaded, you would have begun to see some interruptions in the Zoom call. If it is not happening, it means Zoom is running on a separate thread, most probably, or a separate core is able to handle all the Zoom load, separate one the browser load, and then a separate one is running this one of them is very busy right now. One of these cores is running at 100% capacity, trying to calculate the sum from 0 to infinity. But the rest of them are doing this terminal, Zoom call, so on and so forth. Great question to ask at this point is, Harkirat, you are on a 10 core machine. Does that mean you can only have 10 applications running because each core will handle one application? Not exactly. If you've gone through a class on operating system, you can have multiple applications. They interleave between each other. Of course, if I start multiple applications that are infinitely running a for loop, then none of them will be idle at all, and they'll still keep interleaving, but the processes will become extremely slow. Versus when you have a browser, a terminal, a Zoom application, the CPU doesn't need to be working all the time. For example, right now I'm sending you video at 30 FPS, which means I have to send one chunk every few seconds, every few milliseconds. So I don't need infinitely running. I don't need 100% of this virtual CPU, this CPU's compute. I might be like, bro, I'm going to send something to the other side, this video to the other side on Zoom to my friends once every 30 times in 1 second. So please send it once, and then you are free for the next 300 milliseconds or 30 milliseconds. Then please send another frame, then free. So they can remain idle from time to time, and they interleave. The same CPU might be first running my browser code, then might be running this terminal code, then might be running Zoom, so on and so forth. But one of them is very busy right now. How can I confirm that? I can open another terminal where I can run htop, which lets me see the stats on my machine. And what does it say at the very top? What is the most computationally expensive process running on my machine right now? It's this one at the top, which is node index.js. What's the second most computationally expensive? It's OBS, that's recording the video right now. What's the third most computationally expensive? It's Zoom app, that's sending the video. And everything else is like 8%, 2%, so on and so forth. But 99.3%, which means completely using the powers of one of the cores. What is that process? That is the infinitely running for loop. That makes sense as well, right? If you have an infinitely running for loop, and if you're on a machine, you want CPU is not like an employee who has labor laws. CPU can run at 100% capacity forever. So if you have an infinitely running for loop, then of course it will run forever. Harkirat, why is it less for OBS and Zoom? Because Zoom might not need to, as I said, send everything at every point. At some point, it might become free from time to time, which is why it's not able to use 100%, or it doesn't need 100% of any CPU. Harkirat, what if I start 100 applications? Then what will happen? What you would expect? They will begin to chop out. Why? Because even though this for loop should ideally keep running, the OS will not have the time to pick it up from time to time and run it, and hence it will slow down. That's what happens when you open GT on a very old laptop, right? Hopefully this is clear. KR1 CPU is being used by this guy. Now the question you might have is, Harkirat, तो फिर Node.js is extremely powerless language. You should never use it. It only runs on a single thread or a single core, and you are on such a big Mac machine, yet you're not able to use it to complete power. Sort of true, but you can do a bunch of things. You can do this. Okay, yaar, theek hai. I have to do something computationally expensive. Let me start multiple Node.js processes. Let me start 3 Node.js processes so that I'm able to use 3 CPUs. Of course, it becomes very hard to share data between them. They can't really talk to each other, which is something you can do in a language like Golang or Rust. But you can be like, it's fine. At least the infinite for loop is running in 3 places. So I have 3 workers that are doing work. I was able to parallelize Node.js. My Node.js runs on multiple threads or multiple vCPUs. My Node.js is multi-threaded. Can you say that? You can technically say that. You can if you're on a big machine, you can run multiple Node.js processes in various terminals. And what would that do? If you look at desktop now, you will see the top 3 processes are node index.js, all of them running 100%, 100%, 100%. So can you make a Node.js process use all the power of your machine? Yes. Then why do I need Golang, Harkirat? As I said, number 1, this is very ugly. Opening 3 terminals, doing this. It would be nice if I run a single command that's able to parallelize. Number 2, it's very hard to share data between them. If this thread wants to send some data, this thread becomes very hard. That becomes much easier in languages like C++. That becomes much safer in languages like Rust, which is one of the reasons that Rust was introduced. Rust needs to be extremely memory safe when it comes to cases like these. If you're spawning 2 threads, they should be able to allow to share data between each other, like amongst each other, without having dangling pointers or things like these. So we have found a weird way to make Node.js sort of work on a beefy machine and extract all of its power. But let's see how the same thing happens in Rust. If you were supposed to do the same thing in Rust, would you run 3 different Rust processes, or can you do something better over there? If you don't understand this code, it's fine. This is, syntax is a little different. We're using something called the thread. Think of it as pseudocode all along. I've defined a main function. I'm iterating from 0 to 1 to 2. So I'm running 3 iterations of this. And rather than doing, a for loop over here infinitely, I'm first spawning a thread inside which I'm creating a counter and then running a for loop. I'm not running the for loop directly outside over here. I'm first spawning a thread, and then in that thread, I'm sort of running the for loop. And then I have another for loop in the main function call. So when I start this function main, when I call this function main, when I do the Rust start, let's say, what happens? Control reaches here. 3 threads get spawned. 0.3 means it will run 3 times. 0 for I equal to 0, I equal to 1, I equal to 2, or underscore equal to 0, 1, 2. And it will spawn 3 threads, which are also overworking. They are running an infinite for loop. And then the main function will also run an infinite for loop. So we ideally have 4 processes running, or 4 threads running. 3 of them trying to, find some sum. This one just ideally running and, not doing anything at all. And if you don't understand this code, it's fine. I hope you theoretically understand it. We're spawning a thread, which means, this is the thing that Harkirat said Golang provides you, or Java provides you, or Rust provides you. It lets you spawn threads where you can, tell another person, okay, please do this job, or tell another vCPU, okay, this can be run on a different machine, a different CPU, this can be run on a different CPU. That's exactly what we're doing here. If I try to run this, and it's fine if you're not able to run this, we don't have the Rust compiler locally right now. I'm just pasting this in a file called main.rs. Will this work without a cargo? It won't. I'll have to do it in. Okay, let me initialize an empty Rust project. mkdir week 22. So if you have cargo locally, which means, the package manager of Rust, very similar to npm. How do you initialize a empty package.json? You run npm init -y. Similarly, how do you bootstrap a Rust application which has the equivalent of package.json, which is cargo.toml here, the equivalent of index.js, which is, whatever, main.rs here. You run cargo init. When I run cargo init, it initializes a Rust project for me. If I look at the files, it has a cargo.toml file, which is similar to package.json. It also has a source folder, which has the main.rs file, where I can just replace the contents of this to be the code that we have. Cool. So I've just initialized the Rust project. How did I do that? Cargo init inside the folder where I want to initialize it. And what is the second thing I did? I've replace the contents of main.rs. Now I can run this Rust project locally by typing cargo run. Gives a bunch of warnings, that's fine, and then remains stuck over here. Notice what happens here. What does this say? It says, yeah, there is a process using 385%. What does 385% mean? It means 4 vCPUs. It's using 4 vCPUs or 4 CPUs. And what is the process? It is this cargo run process that's sort of running Rust on my machine. What does this tell you? I did not have to open 4 terminals. In a single terminal, in a single Rust file, I told, okay, bro, you run an infinite for loop and also spawn 3 threads that do the same thing, that run an infinite for loop. Of course, in the real world, you're not running infinite for loops. You'll be like, it's a handle request that's coming from a user, an HTTP request, or, as I mentioned, a use case of, finding the sum from 1 to 100 billion. Then you'll be like, the first thread, please find the sum from 1 to 100 million. Second thread, please find the sum from 100 million to 200 million. You'll get all of these values and then finally add them up and return them over here. You'll parallelize this. That will be a real world use case. But hopefully it's clear that a language like Rust, or even as I said, Golang, where you can create subroutines, and Java, where you have a thread pool that lets you create threads, does the same thing. You can have something using more than, one CPU of your machine, which is good. Which is great for, a backend application, because you want to scale backends as much as you can vertically. If vertically doesn't work, you do scale horizontally as well. But, for the first 100,000 users, scaling vertically is great. And it's much harder to vertically scale in Node.js. Can you do it though? You can. This should say vertical over here. Implementing vertical, not horizontal, vertical scaling in Node.js. Let's say, I say कि फिर भी you have to implement vertical scaling in a Node.js process. Somehow figure it out. Firstly, let's do a poll. Do we understand everything I've taught until now? Let's take some questions really quickly then. 82%. I think 2 or 3 questions or a recap will be fine. So, small 3-4 minute break. If we split a big calculation into small chunks, wouldn't it create issues? One core going down, unavailable. Wouldn't it be better to maintain atomicity and then let one transaction task be performed on one core? If a core goes down, you can always respawn a core, and then, a thread goes down is what you're saying. Just respawn it into it. Then to never auto scale only. So you are saying, to maintain atomicity, we should never, scale horizontally or vertically or horizontally to maintain atomicity. But do you really need atomicity here? You just need to find the sum from 1 to 100 million. If you split it correctly into the right chunks, and as long as the threads are doing the thing they're supposed to do, you're fine, right? Node.js has worker thread too. This is the first one. You can also, so you can execute other processes from Node.js. So you can still, one Node.js process can also spawn another Node.js process that will pretty much do something very similar to a thread pool, I guess. So yes, it does not give you access to a thread pool. It does not let you do lightweight multi-threading. But yes, you can always spawn one Node.js process can always spawn another Node.js process, and or another C++ process, and then that second process can use another core of the machine. If we answer that. Can you explain what increases when we scale vertically? What are vCPUs? Stand for virtual CPUs, because when you're on an AWS machine, they're just called vCPUs. How did you start multiple Node.js process parallelizing it, and how help fast computation and we making 3 different Node.js files and dividing 3 tasks? Yes, that's one way to do it, right? I will just create 3 different Node.js files. First file will find the sum from 1 to 1 million. Second Node.js file will find the sum from 1 to some other big number. 1 million to 2 million, so on and so forth. Yes, that is one dumb way to do it. Of course, you shouldn't do it that way. There are other ways to split this calculation and share data amongst various processes. Someone, for example, mentioned worker threads, so you can always spawn 10 processes, get the response from them. So you can actually do. Technically, if you think about it, yes, you can actually do this in Node.js. So if this is a single Node.js process, it can actually spawn other Node.js processes and get the final response or STD out from them, and do whatever it wants to is supposed to do with them. So you can technically spawn more and more processes, but spawning a process is much more heavyweight than starting a subroutine, for example, in Golang. So yeah, that's a difference. But yes, you can always do this. Start multiple processes rather than running node index.js 10 different places. The first process itself can be like, nahi yaar, I'm going to this first parent node index.js that you run can have code that looks something like this. Yaar, spawn node index2.js and then spawn node index3.js. So it will start, let's say, a bunch of other JavaScript files that pretty much calculate whatever they're supposed to calculate. And of course, since it's a separate Node.js process that's running, then you can of course run. It'll of course run on a different CPU. Reshare screen, please. Stop share. Reshare. And can we see the high CPU usage on Replit? Also for that Rust example showing high CPU usage. It will, right? It's running an infinite for loop. It should show high CPU usage. And also don't trust the Replit CPU usage. You don't exactly know what's running, how many cores it's giving access, how many cores of CPU is it giving you access to. Did you start local recording? Yes, I did. If Rust is better for creating backends, why companies prefer Node.js? Because Node.js is easier to write. Rust is much harder to write, very hard to hire for. A lot of times you don't need all the optimizations it provides you. You only need them when you need very, core access to memory. And we never worry about core access to memory in a full stack application. You're creating an e-commerce website. Kya farak padta hai? The only problem is, it's harder to scale vertically. But as I said, you can very easily scale it vertically by using cluster module, and then a bunch of people suggested, you can spawn other processes, things like these. But how does ChatGPT use Node.js? No idea what that question means. What are worker threads in Node.js? Worker thread, that's a good question. Even I will have to look. I would assume it's the thing that lets you, that sort of runs when you spawn a process. Worker is main thread. Promise worker is new worker. Yes, I would assume. So you don't quote me on this. Kit lets you run another file, or start another Node.js process from this process. Is that what it is? Someone already sort of mentioned this. Let's see. Worker new worker file name. I would assume you give it a file name and it starts that specific Node.js process, very similar to spawning it. Is that right? Could be wrong. Let me open chat. If someone knows what a worker thread Node.js does, or workers in Node.js do, chat is open. No one knows. Correct. All right. Cool. May you explain vertical versus horizontal scaling? We're coming to horizontal scaling very quickly, but briefly, if you have a single machine that you vertically scale, which means you keep adding more CPUs to it, you keep adding more RAM to it, that's what vertical scaling means. Because as you can see, theoretically think of it as you're increasing the size of this specific machine and hoping your process scales very well, and it can handle more load because you now have a beefier machine. From first principles, you might think of this, right? Yeah, if I have a bigger machine, then of course it will work. In fact, I would, a bunch of the startups I worked at initially had a Node.js process and would hope by scaling the machine it would perform better, but it doesn't. Horizontal scaling means, okay, yeah, you have some size of machine, let's say 5 CPUs, 10 CPUs, and you increase the number of servers. So just scale the number of servers up. And if you look at it technically, you're horizontally scaling because you're adding a bunch of similar servers horizontally. Vertical scaling, okay, the same server I'm going to increase the size. Why there is thread pool in Python if it is single threaded? I have no idea. Python is single threaded, probably lets you spawn threads as well, and that's probably the reason why it has a thread pool. Can we use fork? Yes, exactly what we're coming to, but yes, you can fork, and that will pretty much let you handle multiple requests on various cores. That's what the cluster module, that's exactly what the cluster module lets you do. Small recap of the coding part. All right. The recap of love the questions, guys, by the way. The coding part is, if you're running a very expensive thing, which, an infinite for loop is a pretty expensive thing. It will keep the worker busy forever. Whatever is running that specific Node.js process, whatever is running that specific process will be very busy forever because it's literally doing nothing but increasing a number from 0 to infinity. You can also make this a smaller example and find a sum from 0 to 500 billion. Then also it's a very expensive thing. So if you have this very expensive file, JavaScript file, what do you mean by expensive? I mean this will take it a long time to find what is the sum from 0 to infinity. In this case, it will keep on running infinitely. So what did I do? I started this JS process locally. I ran node index.js. And what did I see? If I run it in 3 terminals, I see 3 processes here using 100% of the CPU. I never see a single process running, 1000% of CPU. Even though I have 10 cores over here, as you can see from 0 to 9, the single process is not able to take 100% of it. It cannot take over all of my cores. But that is not true for Rust if you're creating a thread pool and starting multiple threads. That is also not true for Node.js also if you start worker threads, as someone mentioned, or spawn a bunch of processes. But here it gives you constructs to spawn what are called threads, which are much more lightweight than starting another process. Of course, Node.js can start another process, so can Rust. But threads are more lightweight when they start another process, when you want to offload work to another core. And that's what we do here. What do? We define a main function. We iterate 3 times and spawn 3 threads to do this expensive operation. We also do an expensive operation here, which means 4 things are parallelly doing expensive operations. And how can we confirm that? When we ran htstop here, we saw 400% CPU, which means 4 CPUs are being used to peak capacity. So in the same process, we were able to do this. If we do use worker threads, I'm guessing here, but I most probably will be right here. If you do use worker threads, you will still see 4 processes here, 4 Node.js processes, each running at 100% capacity. You will not see a single Node.js process with 400% capacity. If you do use worker threads, if you do spawn multiple processes in Node.js, which you can, you will still see 4 processes here, 100% each. You are just, finding a cleaner way to start 3 Node.js processes rather than, the same process running multiple threads. So ideally we ran Node.js application on 3 cores. Doesn't that mean we created 3 servers? Yes, you created 3 servers, which, will create issues. If you create 3 express servers, they will try to use the same port. So that will be a problem. We'll come to that in the next slide. But yeah. Cluster module just creates 1 copy of Node.js, doesn't share memory. I don't think you can. Yeah, pretty sure you cannot share memory. If you want to share memory, you have to do IPC. You have to do inter-process communication. You can still, have variables from one Node.js spawn go to the other one using IPC, but you cannot, natively share them. If JavaScript is single threaded, then how it performs asynchronous tasks? Great question. Very popular interview question. How many people have this question? If JavaScript is single threaded, how does it perform asynchronous tasks? Oh, I asked it incorrectly, but it's 50-50 only. A lot of people have this question. And the answer is, I mean, we've discussed this when we initially shared what the call stack is and event loop is and how things are done. If you remember, there was what was this called? Stack. What is the website? I forgot the name. Stack, and then callback queue. What was this called? I totally forgot. 1 second, guys. Hello. Yes. I thought the video is incorrect or something, so I picked up. You have a stack where anytime there is an async stack. What is this? Probably called something else. So don't quote me on this. I can just open and see what it means. This is your main. This is the call stack. And what was this? What is this called? What is this called? What was that website? Bowl. Someone in chat will tell me. What is the thing on the right called, guys? Latent flip. Web APIs, or not just web APIs. Anything that's offloaded tasks or asynchronous tasks like database calls as well. So what happens when you run, if this is your Node.js file, let's say app.get /rec_rs, and you do await db.user.find1, something like this. Let user equal to this thing, and then whatever, return res.json user. Let's say I have two of these. I have a get and I have a post. Okay, let's say they do the same thing. Let's say both of them get called at the same time, which means two people are sending requests to my website almost at the same time. Since JavaScript is single threaded, it cannot handle both of them together. This though is the truth. It will not. It's not like it will be able to be like, I will run this and this line at the same time. The let line here and the let line here will not run at the same time. So one of them, whatever came first, will go here. In fact, even the control comes here through this lifecycle only, but ignore that for now. The control reaches this line, let user equal to await db.find1. Now, when this await db.find1 happens, what is happening? A database call is happening. We are sending a request to a database, or in case of web APIs, let's say you are doing a fetch over here that actually sends out a request. That thing is offloaded to the web APIs section / database calls section, and is most probably 99% running on a separate CPU. The actual process, that is most probably, don't quote me on this, so this could be wrong. This most probably is running on a separate thread. For example, if you're running it in the browser, the actual fetch to send out the request is being done by C++, like the browser in C. Could be wrong on this, so don't quote me on this. This request goes out to whatever database and eventually comes back. And when this is ready, when this database call is done, is when it gets put here in the callback queue. KR, the DB call succeeded. This is the response that you got back from it. What was this? Callback queue. What was this? There was one thing over here which was called event loop. So the first request came here. Control, this line is pretty much running currently on the stack, or currently on the CPU. It runs this line. It's like, okay, I have to get some data. It offloads this task over here, and the database call is happening. While the database call is happening, it moves on to this other user request over here, and then that call also gets offloaded over here. And now, while these two tasks are happening here, while this callback queue is completely empty, it can do a third thing. If there is another request, it can keep piling up this over here and be like, okay, I've sent this task to a database call to someplace else. Let me do whatever I was doing. Are there more requests I need to handle? It can start to handle them. And then eventually when this task is complete, it gets pulled from here to the callback queue. Whenever the thread becomes free again is when it pulls it from the callback queue and executes the rest of the things, which in this case would be rest.json user. And then the same thing happens here. Whenever this succeeds, comes here. whenever this rest.json happens, the thread becomes free again. This things move from the response from the callback queue moves over here, and then you can do whatever this second request handler is supposed to do after this line, which is let the user know, hey, there you go, this is the response. The only question here is, where do all of these offloaded tasks run? When I send a fetch request, does it happen on the JavaScript thread, or does it happen on a separate thread? I'm sure it's Googleable, and some of you have already Googled by now. So tell me, does it happen on a separate thread? And my answer is yes, it probably happens on a separate thread. Yeah. So yeah, JavaScript is still thinking that. So JavaScript is not supposed to do the fetch. JavaScript is supposed to offload the fetch to someone else. While they are doing the fetch, it will do its own thing. That to make JavaScript multi-threaded, not exactly. The crux of JavaScript, the lines of JavaScript, the for loop, the while loop, whatever you're running over here, those lines can only run one at a time. Versus, if in Rust, even those lines you can, parallelize. This for loop runs over here as well. So now is that question answered? Okay, even though JavaScript is single threaded, how does it run asynchronous operations? This question sort of is a great question to ask to check someone's fundamentals. Okay, do they fundamentally understand JavaScript or not? Great. Cool. Shall we proceed? Can we move on to, the cluster module? Are we good to go, guys? Or do we need more recapping? I'm assuming so. Are we good to go? All right. Not taking a break. We can take one later on. 87% is great. Let's proceed. Implementing horizontal scaling in a Node.js project. Let's say you do want to implement horizontal scaling. If you're like, I have to have a very beefy machine. I want my million users to go to this single beefy machine, and I want to use Node.js only. What can I do? You can either start multiple node projects, and you'll be like, okay, I will just start node index.js 10 times. And then, my machine is running 10 different Node.js processes, and hence I have used all the powers of my machine. But this has a lot of problems. First, this is a very ugly approach. Slightly better approach is just spawning multiple requests on a worker thread that someone suggested. Number 2, processes will have port conflicts. The biggest issue here is, if you start multiple processes together, if this is an Express server running on 3000, you cannot start another Express server running on port 3000. You cannot be doing this. There'll be a port conflict. If you want to try it out quickly, try it out. You might have already seen this from time to time, but let's see if I have a Rust Express project somewhere here. Let's just do it on a next step. Cannot do it here. Which of these is an Express project? Week 14 isn't. Oh God. Let me quickly create an Express project, even though I'm assuming this is pretty straightforward. We'll say cd Express project. Import Express from Express, const app equal to Express, and then app.listen 3000. If you write code like this, of course there'll be a bunch of handlers here, but assume there are no handlers, and run node index.js once, it will tell you don't have Express. You also don't have package.json. So npm init-y, npm install Express. I'm not using TypeScript. I'm simply using JavaScript. Let me open this in Visual Studio Code so it's easier to look at and understand what's happening here. If I run node index.js over here, still gives you an error. Okay, you cannot import like this because this is a JavaScript project. Equal to require. There you go. You have this, Express project, let's say. Cool. If you run this once, it's all good. You have a single thing running on port 3000. If I go to Google Chrome over here and go to localhost 3000, it says message hello world. But if I try to run the same thing in another terminal, I repeat, I open another terminal and run node index.js, what happens? A port conflict happens. It says address is already in use. You cannot start another process that's running on the same port. So the naive approach that we were talking about, Hakirat, we will do this, we will start multiple node index.js, does not work. So what can we do? We can use the cluster module. This might have changed recently, by the way. Someone mentioned worker thread, so maybe they are a better way to do this. But historically, cluster module is something I've used, and that also has recently changed its API. So, today when I was doing this, I realized cluster.isPrimary is depreciated, and there's another way to, start multiple or spawn multiple processes using the cluster module. So, feel free to Google a little bit also after the class to figure out is there a better way to do this today. But this was conventionally the way to, scale Node.js applications for the longest time, probably is today as well. What does it say? It says import Express from Express. Firstly, we'll do whatever we were doing like importing Express like we were until now. Import cluster from cluster. This cluster is something that Node.js provides you, which means it's a Node.js internal library. You don't have to do npm install cluster. It comes pre-built with Node.js, very similar to, FS or HTTP. All of these come pre-built with Node.js. You don't have to externally install them. Import OS from OS. This library we are only using to find the total CPUs that exist on this machine. Const total CPUs equal to os.cpus.length. This will give you, in my machine, this will print 10 because I have 10 CPUs on my machine. Const port equal to 3000, nothing too complicated here. Now comes the mildly complicated bit. If you've done, forking in the past, then this will be straightforward. If you haven't done forking in C++ in the past, then this might seem a little overwhelming, but bear with me. What are we doing eventually? We are starting multiple processes somehow, which means this file that you see here will run multiple times. It might run 10 times or 20 times, which means the same code is going to run for all of these workers, right? Yes, Arkita, the same code will run. So what this if check over here does is, is this the user started process? Eventually, I will start a process by running node index.js. And this process needs to start a bunch of other processes, right? I will start a process by running node index.js, which we want, it spawns 10 different processes that handle all the incoming requests. So what does the cluster module say? It says here, if this is the primary Node.js execution, which means if this is the Node.js index.js process that's running by the user, then run this code. And what does this code do? It says for let I equal to 0, I less than total CPUs, I++, cluster.fork. What does this cluster.fork do? It starts another process that pretty much runs the same thing, which basically means that process will also start from the top and try to run all of this. But for that process, cluster.isPrimary would be false, which means the control would reach over here. And here you can write all of your express logic to do whatever you're supposed to do. And if you are using the cluster module, there will be no port conflicts. Even though you might feel like we are still starting 10 processes, there should be a port conflict. There will not be another port conflict if you are using the cluster module to fork the same process rather than starting Node.js process again and again in a terminal. The biggest thing that will feel overwhelming over here is this cluster.isPrimary path. What it basically means is, you will run node index.js once in your terminal. And once you do, the cluster.isPrimary variable will be true over here because this is the primary execution of this index.ts file. This index.ts file is running from the top, and this is true because this is the user started node index.js. But this ends up forking 10 times, which means this ends up starting another 10 processes. It ends up starting node index.js, let's say 10 times. But for all 10 of these, cluster.isPrimary is false. For this guy, it was true. For all 10 of these, again, the code will start executing from the top, but the control will reach the else statement where you define your express logic that actually handles the request. What is the express logic? Const app equal to express. It also prints on the screen worker process.pid started. What does this tell you? Every process will have a separate PID, which means these aren't lightweight threads that you're starting. You're starting multiple processes. This is starkly different to how you do it in Golang, where when a request comes, you spawn a subroutine. Okay, you handle this request, you handle this request. Here we just start 10 processes They are actually separate processes. Only it's just cleaner for us to write, and there is no port conflict. A single node index.js is able to start 10 processes, all of them listening on the same 3000 port over here. A simple route, hello world route. A slightly better route, app.get/API/:n, which means if you want to find the sum from 1 to some number n, this request handler will do it. If you look at the code, that's exactly what it does. It gets n from the parameters, starts count equal to 0, let count equal to 0. If n is greater than a very big number, then we pad it to a small number, and then we iterate from 0 to that number and increase the value of count, and then finally return that to the user along with process.pid. We want to eventually debug, okay, are multiple requests being handled by different processes, which is why we also send back process.pid here. What is process.pid? Whenever you start a process on your machine, it has an associated process ID, PID. If you start a node index.js, if you do a go run some Golang file, every process that you start, even my Google Chrome browser that I have here, has a PID, process ID associated with it. And this log over here should confirm, okay, we are able to start multiple processes. Let's try to run this code and maybe see we understand something better with the code. Pasting the code here again to quickly go over it from top to bottom. Bunch of imports. You can also hardcode this. If you don't want to use OS, feels overwhelming, hardcode this. If you have 5 CPUs on your machine, hardcode this to 10 or 5. If cluster is primary, we put a bunch of logs and then we fork the process 10 times. We also say, okay, if one of these workers exit, please fork again, so that if it does, one of the workers do end up crashing for whatever reason, we restart it again, so that we still are using 10 CPUs on our machine. So if any of them stops, you do this. You can also be like, I will exit the parent process, which will exit every other child process as well. When this happens, a lot of times this is the approach. If one of the worker dies, we kill everything, and then PM2 will restart the application again, and that's how the restart happens. Or you can just be like, yeah, if one of the workers stop, I will just do a cluster.fork to again restart it. What does cluster.fork do? It restarts this file again. It starts a new process with the same file, but this time cluster.isPrimary is false, and control reaches here, and you start an express server that is listening on port, whatever was the port over here, 3000. Let's run node index.js. We cannot, because we have these kinds of imports. Let's convert this into a TypeScript project. Try this later on. Let me just quickly do this, and you feel free to try it in your own time. You can also try it right now, but again it'll take some time for you to, I guess, not like npx tsc -, that's all I did to initialize a tsconfig.json, and then I'm going to replace index.js with index.ts because this is TypeScript code. Then let me do npm install express. Why does cluster there we go. Npm install express, npm install at type/express. Notice I did not have to do an npm install cluster. And then this is the code. If I compile this, how do I compile this? tsc-b, it will create an index.js file. It is creating it in the root folder because I did not update tsconfig to have a root dir and an out dir, which is something that we usually do. But today I did not do it because we have a single index.ts file. This is the TypeScript file. I ran tsc-b to convert it into a JavaScript file. Let me run node index.js. And it keeps on erroring because I have something already running on port 3000. So let me stop and let me restart. And notice what it say. What does it say? Worker, this thing started. Worker, this thing started. There are multiple processes that I have running with different PIDs, which means they are different processes. They aren't lightweight threads. They are different processes that are now handling requests on port 3000. If I go to localhost :3000/API/10 or 1000, what does it say? It says final count is 500500 and a process.pid, which is 91296. There is one small problem with this. What would you expect when I refresh this page? You would expect the PID keeps changing, but notice the PID remains the same. It did change initially, but now if I'm refreshing, it remains the same. It will remain the same for a while, and then eventually if I refresh again, you'll see it will change. Which means even though we have multiple processes, the same one is handling all the requests here. Does anyone know why? Because the answer is I don't know why. Statefulness is what I thought as well. Maybe caching, same API, caching where? Just single threaded, that's the wrong answer. Do worker threads run on far left core of the CPU? I don't understand that question. It checks for parent process, for child process, copying the parent one. Yes, exactly. Cool. I guess no one knows the answer. I'm assuming it's somehow, the request when it goes out from the browser, it has some sort of a fingerprint. As you can see now it changed. But it has some sort of a fingerprint, and then the backend is like, nature, I will return it from here as well. This does not happen if I start another browser. If I start a Brave browser, it is handled by 91288. Here it is handled by 91292. If I send the same request via curl, you will see 91291. So it does happen it is multi-threaded. Firstly, I thought this isn't working only. When I was testing this out before the class, I was like, I'm refreshing, why is this not changing? Then I realized it's probably, something is up with how the backend handles requests from the same device. And just pipes it to the same core for some reason. I don't know what the reason for that is. But if you wait for a while, then you will see the PID change. For example, if you wait for like 10 seconds, then it changes. But if you keep refreshing with no gap of 10 seconds, you will notice the request goes to the same PID. I don't know why. Probably something on the backend. Cool. That's pretty much it. That's how you do, vertical scaling in Node.js. And try to figure out the stickiness thingy. I have no idea why this happens. Why it gets routed to the same PID. Capacity estimation. All right. So I don't know. It could be a break time. We could take a small break. How's it going? Should we take a break, guys? Yes or no? I can answer some questions during that time. I don't think we'll be able to reach indexing today because we have to do some backend stuff. Should we take a break? And that is a yes. So we will take a break. We will restart in 9 minutes. So at 7:15, I would assume that would be in India time. So let's restart 7:15 India time. Until then, let me answer questions. Let me open chat here. So feel free to ask questions. We'll go from there. Recap. Too many recaps already. Recap from the top. What were we discussing today? Generally, we will only be able to understand cluster module, horizontal scaling, and vertical scaling today. And capacity estimation as well. I'll take you through an overview of ASGs today. Tomorrow, we will try to write some code in ASGs. And tomorrow, most probably, we'll understand load balancers and indexing. These two will either be an offline video. Anyways, not super important concept. Maybe normalization is important, but we'll see. Probably be an offline video. So we started off with vertical scaling to begin with. What does vertical scaling means? To begin with, why even scale? You scale because your application needs to handle millions of billions of users eventually. Initially, it has only 5 users that are your friends. But eventually, most applications, good companies, have millions of requests. So they have to scale somehow. Now they can scale 2 ways. Either they can increase the size of their EC2 machine, which means vertically scale, or they can add more and more machines to their fleet. Here I have 3 machines running, and any incoming request will first go to some load balancer, which will load balance this request across all 3 of these machines. This is called horizontal scaling. So you can either vertically or horizontally scale an application. Question is, what can you do in Node.js, and what should you do in Node.js if you're horizontally or vertically scaling? For vertical scaling, it's slightly harder in Node.js because Node.js was never meant to run on multiple cores. JavaScript was meant to be single-threaded. JavaScript was built for browsers, and for some reason they thought, JavaScript needs to be single-threaded. Whatever JavaScript needs to do, which back then was manipulate websites, a single thread is good enough for that. So JavaScript never had a concept of creating a thread pool or starting multiple lightweight threads and running them on various cores. And a single process, single thread, it'll keep on running. That's why it's called single-threaded. But we try to find, first principles ways of how can you get around this. Can I start multiple node index.js? That way I have multiple processes running. And, I have been able to parallelize my Node.js server. I have multi-threaded Node.js. The answer is probably not. There will be port conflicts when you do this. And so we said, here, to avoid this, we use something called the cluster module, which what does it do? It lets you fork your process. What does forking mean? Start another child process that runs the same code. Only the is primary variable for that child process is false, which means when the control does reach here for a child process, control goes to this else and it starts the express server that will now handle incoming requests. So if I have 10 cores on my machine, the very first parent request will reach the if, and then will fork the process 10 times, and then the else is what gets called in every child, which actually start handling incoming requests. Then we ran this code locally. I went to Visual Studio Code, sort of copied everything, and ran node index.js. I saw in the logs, what do the logs say? It says number of CPUs is 10. Primary is running on 91287. And then a bunch of small mini workers have been started that run on 91296, 91289, 91210, so on and so forth. That is what the logs say, which means, control did reach here. And when I send a request from my browser, it does say final count is something and the PID of the process that's handling this request. So if I go here, what did I write over here in the /API/:n handler? I do some computation and then eventually run the count as well as the process.pid. And we were just able to confirm that the PID changes. If you, refresh this again and again, there is some problem there. For some reason there is stickiness in the same device. If I send the same thing from the browser again and again, this PID doesn't change. We'll have to figure out why. But if I send it from various, different devices, which is what will happen in the real world, you will have people all around the world. Then it's being handled by different processes. We were able to somehow vertically scale our application. It was very weird how we did it, but we were able to do it. In a very, very weird way, Express can, or Node.js can start multiple processes to handle incoming requests on various cores. That's all we have done until now. Next, we were moving on to capacity estimation. Let me open chat again. If you didn't know the answer, why did you ask this question? This one, I have no idea. I mean, I asked because does someone else know why there's stickiness? There is not a lot of stickiness. If I refresh now, 91289, it becomes 9210. I want to check if someone knows the answer. Maybe give a bounty, but I don't know. Maybe probably is a hard thing to figure out, or maybe Googleable. I don't know. We'll open chat again so you can let me know. If I start 10 terminals or one, is it utilizing more than 65%? Remains same with terminal 1 or 10. Why? If I start 10 terminals, I'm assuming you mean I start node index.js in 10 terminals or one terminal, it's utilizing not more than 65%. Remains same with other. Okay, so you said you have 10 vCPUs on your machine and you're running node index.js with a very heavy operation in 10 terminals, yet your machine is only able to reach 65%. Yeah, there are a few reasons for this, right? You might have other processes running that are being interleaved. So, just because you start 10 Node.js processes infinitely running doesn't mean your machine will stop doing other processes. It might interleave to, a Google Chrome, a terminal, a Zoom meeting that you're on. And those might be idle from time to time. So when it interleaves to Zoom, it might be idle for some small time. And that is what, decreases the net CPU usage on your machine to, 65%. Request to move class timings. Probably harder because, there's something that's committed. It's very hard to move back from it. Probably won't happen, unfortunately. Even if a poll is, 10% people say we want to stick to this timing, we'll have to. Can you explain the horizontal scaling architecture logic again? Yeah, we'll come to that next only. So we've discussed vertical scaling. The next topic for us to discuss is horizontal scaling only. So we will reach that in slide number 5. Clusters in Node.js are good enough to run multiple instances, whereas worker threads allow to run multiple application threads. So worker threads let you do this, seems like. So you can start threads now in this is cluster based threads. Maybe you can. What are worker threads? Worker threads in JS. Experimental stage. Worker threads. We should run JavaScript code in a separate thread to parallelize. Seems like you can do that. We probably should do a follow up class on this and figure out what this is. All right. Maybe because of re-render? I don't know. I don't know why it was stickiness. I've guessed a few times. I first thought, there's some cache response coming here. So I refresh this. But, the status is 200. There's like some 302 or something like some status code that will give you a cached response, but I don't think that this is that. Yeah. One way to debug this might be put a log on the backend and see, does every time that I refresh, does the request reach the backend? Maybe the request isn't reaching the backend. The browser is somehow caching the request. All right, we're at 9:55 here. Or whatever. India time, 7:15. Someone asked if I'm in Thailand. I'm not in Thailand. All right, but I will not share where I am for no reason at all. I guess I will share at some point. If Rust is better for creating backends, why companies have Node.js? I answered this. Easier to write Node.js code, easier to hire engineers. A lot of times, all the optimizations that Rust provides you, you don't need. I read this. Node is ideal for building I/O intensive operations. Should you avoid using Node.js for CPU intensive operations? You should avoid Node.js for CPU intensive operations. This is a great point. Node is ideal for building I/O sensitive applications. What does that mean? Node, this is the last question, then we'll proceed. Node runs on a single thread. If you have multiple CPUs, it cannot use all these CPUs. So what does your statement say? It says it is good for I/O related applications which heavily rely on input output. What does I/O mean? I/O ideally means input/output from the user. Here you will ask the user, hey, what do you want to find the sum for? Let's say you create a terminal calculator in Node.js, where you ask the user, hey, what do you want to find the sum for? And the user gives you 1 and 2. This is one good example of I/O, input output. Database calls, fetch requests, you can all sort of you bucket them into I/O. What this statement basically means is, it only has access to one CPU. So don't run, expensive CPU operations here, which are, this is a good expensive CPU operation that you have to run. It says, do not run an expensive CPU operation. Do not run CPU intensive tasks, run IO intensive tasks. Tasks that can be offloaded to other things that have to wait, but can wait asynchronously is what you should use Node.js for. Because, if they're being waited on asynchronously, the Node.js thread can do other things. Diagram. Okay. Cool, guys. Let's get right into vertical scaling. So slide number 4. Before that, capacity estimation. This is one of the weirdest, things we have to sort of check off our things to do. I have a video with Kirti Puswani where we did, YouTube, and the first thing she asked me was, how much video do you think is being uploaded every day on YouTube? So these are the questions that, are asked in these sort of system design interviews a lot of times. This is what capacity estimation means. There are some practical learnings from this, but a lot of this sounds pretty useless to me too, as an interview question. I don't know how much videos uploaded to YouTube every day. I don't follow those stats, right? But a lot of times you are expected to, arrive at a number close to what is that the load of a system like this. What is the expected load? So you'll sort of face these questions from time to time. If you're building a YouTube, how much do you think every users come? How many users do you come every day? How many uploads do you happen every day? How many uploads do you think happen every second? So on and so forth. So practically they become useful if you want to understand how to scale your system. We'll understand a few architectures here: Paytm application, chess application. I'll also introduce a third one. If I forget, remind me. A video transcoder application. This is a common system design interview question where they'll ask you, how would you scale your servers? System design they will never ask you, your system has 10 people, how would you build it? They will ask you, your system has 1 million users, how would you scale it? How would you handle spikes? What are spikes? You had only 10 users and suddenly you have 1 million users. And then you have 10 users again. How would you scale up your infrastructure? How would you scale down your infrastructure? How can you support a certain SLA given some traffic? What is SLA? SLA stands for service level agreement. SLA is basically mean, if you ever use AWS, let's say, or if you use Razorpay, they will give you an SLA, service level agreement. They will say, 99.9% we will be up, which means, in a year we might go down for whatever that is, 30 minutes, but 99.9% uptime is our SLA. And if we go down below that, you don't have to pay us, or you have to pay us 20% less. You get a discount in case we don't follow our SLA, in case we do not do what we promised you. So that is what an SLA is. And the statement is, how do you support a certain SLA given some traffic? Now let's say Razorpay said, you don't have to pay us anything if we don't follow the 99.9% uptime. But if you make such a promise, how can you make sure you always do follow that SLA and never can you go down for more than 30 minutes? These are the questions that are asked. Answers usually require a bunch of, number one, paper math. कि यार अच्छा the SLA is 99.9% and the maximum spike that is expected is a million users, then I should always have some servers running, or I should always every 3 minutes check कि यार should I scale up, so that if there is a spike that happens during cricket matches, and cricket matches happen 2 times a year, then during those 2 times my infrastructure will wait for 3 minutes before it scales up by a lot. So these are the things that you have to think of. What did I say again? I said in capacity estimation you have to put things like these. कि यार अच्छा IPL happens twice every year, my SLA is 99.9%, which means my downtime can be at max 30 minutes in a year, which means whenever this spike happens, I have to recover at max in 15 minutes. If I don't recover in 15 minutes, then I've failed to follow through on my SLA, which means whatever is the logic of mine that auto scales servers, that brings up a lot of infrastructure, needs to keep checking probably every 5 minutes. Okay, is there a spike? Do I need to auto scale? Whenever a spike happens, a spike like IPL happens, what you do is you go to a bunch of providers. The IPL bandwidth that is expected to be handled in India, whenever people are watching, 20 crore people are watching the same thing, is it cannot be handled by a single cloud provider. Only AWS does not have enough wires in India to handle that kind of bandwidth. So you have to have multiple vendors available. And whenever the spike happens, how can I in 15 minutes quickly start those vendors? So these are the things that you talk about when you do capacity estimation. Estimating requests per second. There is some obsession that in these interviews with the per second requests per second bandwidth. So if you will say, they'll ask you how many requests do you think come in a day, you will say, oh, there are like whatever a million requests or a million users that will come in a day, or a million active users. So they'll ask, oh, how many requests will each user send? You will say maybe 10 requests. So they'll say, so there's 10 million requests in a day. What does that translate to seconds? So you have to do whatever 10 million divided by whatever the number of hours are in a day, so on and so forth. So 10 million divided by 3600 into 24, I would assume something like this. These are the number of requests that I need to support per second, right? If there are 10 million requests a day, that means there are 10 million divided by 3624 into 24 requests a second. When you arrive at this number, the requests a second number, let's say that number is whatever 100 requests a second, then you have to be like, acha, how much can infrastructure in how much can my infrastructure support? If I have a single Node.js machine in AWS, how much can it reasonably handle in 1 second? Let's say the answer is 10. It's not 10 for Node.js, but let's say the answer is 10 requests a second is what your Node.js process can handle, which tells you what? I need to have 10 machines available because I need to handle 100 requests a second. So that is how you will arrive at the first number. For an application like this, assuming my Node.js process, you of course need a realistic number here. A Node.js process can handle 1,000 requests a second, and let's say the number of requests that you're receiving are 10,000 requests a second. So you need 10 servers available that can handle all of this load. Then they will ask, what happens if there is a spike? How do you scale up, scale down? So assuming you have monitoring that tells you how many requests are coming, and you can somehow spit out the current number of requests per second in the last 10 minutes was this number, you can sort of use this to scale up or scale down your infrastructure. Auto scaling machines based on the load that is estimated from time to time. From time to time, you need to check what is the current load on these 10 machines. And if this load becomes a lot, then you have to scale up. If this load becomes really less, then you have to scale down. So the final architecture looks something like this. Let's say you have 4 machines right now in AWS. All 4 of these are receiving requests from user, and every few minutes they need to somehow aggregate. In the last 10 minutes, I received 100,000 requests, a million requests, a million requests, a million requests. This somehow reaches the system. How it reaches the system, there are multiple ways. You don't have to synchronously do this. You don't have to be like, HTTP request came. Let me send an HTTP request to tell the other side, a request has come. No, you aggregate them. Whenever 1,000 requests come, I will let the aggregated service know 1,000 requests came. Even if this gets missed, it's fine. So that is how you will somehow aggregate. In the last 10 minutes, these many requests came. You will spit this number out to some database or some process, which will be like, oh, the number went up. It will tell the auto scaling group, you need to scale up. You need to bring up 10 more servers. The load in the last 10 minutes has increased by a lot. Similarly, if this load decreases by a lot and this final number becomes 10 requests a second, then this process, whatever this process is that is scaling up and scaling down, this can be different things based on how crudely you implement this. It can be a Node.js process for all practical purposes. I will receive every 10 minutes the current number of requests, and I will scale up and scale down my infrastructure based on that. Do we understand the diagram? When we reach auto scaling groups tomorrow, maybe we'll actually implement this as well. But do we understand, at least theoretically, multiple machines sending data to a single service, which is aggregating the total number of requests per second, and then sending it to a process that's scaling up or scaling down? We don't understand this. Like 80% understand this. So there is some obvious question that I've missed. Can you post it in Q&A really quickly? How many requests can Node.js handle? It depends, right? Depends on how heavy that request is. If this request is simply returning back the user hello, then not a lot of them, maybe 20,000 requests a second. If that process is doing some for loop over 1 to a million, then of course it can handle lesser. There's no port conflict, you said, so means one port is handling all 10 requests. Yes, that is exactly the pro that cluster module provides you. Someone said an answer for cluster PID. Recap. Please come once again. Okay, let me explain one more time. You are an engineer. Forget that this is a system design interview. You are actually an engineer and you created a simple website to begin with. Eventually we'll get into complicated use cases like a real-time game and a video transcoder. But for now, you created a e-commerce website. All right. Right now you have a single server over here on your e-commerce website and it's receiving requests from end users. This is the backend of your e-commerce website. Where is it running? It's running on a EC2 machine, let's say. Users are sending requests here. Let's say suddenly 10 million users come. Some sale happens, everyone's visiting your website. And you have no systems to scale up or scale down. Then what will happen? Your server will begin to get choked. Your users will not be able to receive requests. They will get a bunch of timeouts. They'll just get bad status codes, or they will have to wait for a really long time for a response to come back. And hence, this is bad. You should scale up your infrastructure whenever this happens. The question is, how do you know how many requests are coming? And how can you, based on that, scale up or scale down? One crude way to do this is, not crude, this is actually pretty good. For an application like this, what makes sense is you can create an auto scaling group, which use as a buzzword for now. Tomorrow we'll understand this better. What does an auto scaling group mean? But from first principles, what does auto scaling group means? You give it a number, start 10 machines, and it starts the 10 machines for you. You give it a number, now scale down to 3, and it scales down to 3 machines. It terminates the 7 machines. So the most crude way of doing this is, create an auto scaling group and tell it, bro, your average CPU usage should be 50%, let's say, which means you tell the auto scaling group, if your CPU usage is going above 50%, if it becomes 80%, then please scale up the infrastructure. Please increase the number of machines that currently exist so that this number goes down to 50%. What is the other thing you're telling it? If it ever drops to 10%, let's say all the users leave, it is night time in India right now, then of course no one is visiting your 4 servers. So the average CPU utilization will go down. And then what will the auto scaling group do? It will be like, average should be 50%. I will delete these slowly so that the average, goes up to whatever, 30%. And of course, you always need one machine. You cannot be like, 30 is less than 50, so I will delete the last machine as well. The auto scaling group will of course have a minimum. But you get the idea. That is the most crude way to do auto scaling. But when you are asked this question in a system design interview, they will give you weird use cases. For example, one use case was this. The metric is on requests per second. They will give you, this single process can handle 10 requests a second. And they will say, how will you build a system that scales up and scales down based on the number of requests? So your answer should be, or your implementation also should be, I will have a certain number of machines, and these machines will every 5 minutes tell another, let's say, Node.js process for now, I received 100 requests in the last 1 minute or last 10 minutes. I received 1000, I received 2000, I received 3000. This will create an average. Here, on average, we have received, let's say, 100 requests a second. And it will tell this to another process. Or even you don't even need another process. This process itself will tell the AWS auto scaling group, here, scale up. The number of requests per second that we're handling is very high. So please scale up. And if vice versa, if the number of requests that we're handling on average goes below a certain threshold, then we can scale down as well, because we are over provisioned then. We have too many machines and we can get rid of them to save some costs. So this is one architecture to do auto scaling. When you have constraints like KR, we have a very strict SLA, and the number of requests per second that our process can handle is X, and you need to scale up and scale down whenever this spike comes. Whenever the load might increase slowly, there might be a spike as well. So irrespective of what happens, you need to scale up or scale down your infrastructure. This is the slightly more over-engineered way. This is the most crude and easy way. Okay, give it an average CPU utilization, give it an average incoming bandwidth. If the incoming bandwidth goes above a certain threshold, then also scale up. If it goes below, then scale down. Do we now understand this crude way of doing capacity estimation and scaling your systems? This is exactly what we'll try to implement tomorrow. 50% kind of a thing. All right. I think that was good only. Yeah, 90%. Great. Cool. So now comes a slightly more complicated. What if they ask you, okay, now you have a real-time application. You have a chess-like application. How would you scale now? And in a chess-like application, you don't have requests per second. You have persistent connections. If there are 100,000 people active on your website, they aren't sending you a lot of messages. The number of messages they're sending is low, but they have a persistent connection to your servers. And persistent connections are expensive. You can only have 10,000 persistent connections. There's some metric like this. Okay, for a Node.js process, if you have more than 10,000 sockets open, you'll run into issues. Which means for this real-time application, the metric that you're worried about is not the number of requests, but the number of people currently active on the website. If I go to chess.com, you will see they have this number aggregated somehow. Okay, currently these many people are playing. If you go to a bunch of other live streaming websites like Twitch, they a lot of times have on the top right, okay, currently 8,000 people are active on this website. So you always have this number. How this gets aggregated is a different question. In a distributed system like this is also a challenge. Okay, this machine has 100 connections currently open. This has 1,000 connections. This has 1,300. This has 1,400. How do you aggregate this? And, the answer remains the same. You create a aggregation service like this. Anytime a person connects, this guy tells, hey, I have 1,000 people now. Every time a person disconnects, this guy tells, sorry, I have 999 people now. You can also back this off. You don't have to. Not every change needs to go from here to here. Even if this number is off by a bit, or is slower to finally catch up to the real value, it is fine. You don't need this number to be exactly accurate at all times. So every 2 minutes, they can keep reporting their active users. That number will reach here. And this will send this to the database so that users can see this on the front end as well. You want this aggregated number shown on the front end as well. This will also try to find an average. KR 88,000 people are live. We have 4 servers currently, which means every server has 20,000 open sockets. I need to increase the number of servers because I know, our single machine can only handle 10,000 at a time. So this will tell an auto scaling group. It will tell AWS, please scale up to 8 servers, and it will, the number will get increased. If these connections go down, then of course, vice versa would happen. Another, one very challenging thing that happens here compared to the last use cases, if you had 20,000 people here and you scaled up, you need to slowly drain these users to the other server. You need to move some of these users to the other server, which, requires a bunch of client side logic, which means on your website code, your React code, you write this logic to, disconnect and reconnect to a fresh WebSocket server. The other problem comes when you drain down. Let's say, abhi to we increase the number of servers. What if you decrease the number of servers? Then, this server will die. All the people that had persistent connections here now need to be moved to other servers. So this is one thing that becomes challenging if you have WebSocket connections. This is not a challenge for HTTP servers. For HTTP servers, requests go, request finishes. So if a server dies, it's fine. All the requests will start to get routed to the other server. But for a WebSocket connection, the server that is dying will take down all of these WebSocket connections with it. So you have to reinitiate those connections to a different server from the browser. You probably need to show the user somewhere on the UI, you are disconnected, and then eventually when they reconnect to a server, show them you are reconnected, something like that. But yeah, that's a brief of how you do this in a WebSocket system real-time chat application. Do we understand this? Mm. 82%. Let me share the last one and then let's call it and do questions. So that means we will do horizontal scaling tomorrow, which is fine. Yeah. The last one was a video transcoder. Then I'll open it to questions. The third weird use case is, video transcoder or Replit like website. Or you can say even lead code, but not really. Lead code submissions happen in 2 seconds. Replit pay, you have to give the user access to some compute for, sometimes 2 hours. And video transcoding also takes sometimes 2 hours. What are these 3 use cases? Let me quickly share. And then, the way you scale in all 3 of these is actually fairly similar. Video transcoding means when you go to youtube.com and upload a video ever, I don't know if you've tried it, but when you upload a video, you only give YouTube a single MP4 file. You give YouTube a single MP4 file and YouTube converts it into various qualities. It converts it into 720p, 360p, so on and so forth. 3 qualities. This process is called video transcoding. It is transcoding your 1080p file into various qualities. This can take a long time. This is a very expensive operation. What do I mean by expensive? I mean, converting a 1080p file to 3 variants will take a lot of the CPU on the machine that they're running on. So, if suddenly 100 people come to your website and upload videos, even though 100 as a number is really small, only 100 people are uploading, you need a lot of compute for this. You need almost 100, decently sized machines, because it takes a lot of, time for this to happen, for, an MP4 file to get converted to 360p, so on and so forth. So the question is, how do you scale a system like this, where, okay, you will have a use case where you have to have some compute ready for the user for a long time, because video transcoding takes 2 hours. And if you go to Replit ever and try to create a new REPL in any language, let's say Node.js, then also you have access to basically a Replit machine. I have a video on Replit, so you can look at it. I don't follow this architecture there. I follow a very over-engineered Kubernetes architecture. I do share this architecture there though. Okay, this is taking a long time for me. So when you go to Replit also, then you have access to a machine, because you have a terminal where you run a bunch of commands. They're running on someone else's machine. Same happens on LeetCode. When you submit, runs on someone else's machine. Only on LeetCode, it's like very small. So this architecture isn't really valid for LeetCode. But for the other two, what you have to do is, whenever people come to your website and say, I have uploaded a video or I want to create a REPL, you need to give them access to some compute immediately. What do I mean when I say compute? I mean, you have to give them access to some 2 GB and, whatever, 2 CPU machine. Here, this is exclusively for you for the next 2 hours. When you're doing an MP4 transcoding, it's a very expensive operation for a really long time. Converting 1080p to 360, converting 1080p to 720 is a 2-hour long process that needs access to both the CPUs at 100% peak. So whenever a user is uploading, they need access to some part of your compute. If this is all of the machines that you have in a very big pool, let's say, then you have to sort of share these machines somehow with users. Okay, if the first person comes, you give them access to the first machine. Second user comes, you give them access to the second machine. Third user comes, you give them access to the third machine. Then the fourth user comes, is when the question comes, what happens? Should we auto scale or should we do something else? And there can be multiple answers here. One answer is yes, please auto scale. So what you can do is, okay, whenever a new request comes to create a new MP4 file, or upload a new MP4 file, you can have a warm pool basically of servers. You can have a warm pool of servers. What does warm pool mean? It means they are ready. These machines are ready, but there's nothing running on them. They are ready to get a request from the YouTube uploader service. Someone uploaded an MP4. I will now handle it. And then, another person uploaded, I will now handle it. And as these handles keep on happening, you keep on increasing the warm pool as well. You always have, let's say, 20 machines ready that are warm. By warm, I mean, you get the idea, they're ready. They're not doing anything, but they're ready to pick up requests. If you know, okay, peak, you will only get 20 uploads in 1 minute. If you know, okay, at max, your SLAs, okay, if you send me 20 uploads, I will handle it. If you send me 21, I might not be able to handle it. But my SLA clearly states you can send 20 to me in a minute and I'll be able to handle it. So you probably need a warm pool of 20 at all times, so that, as people send requests, you sort of warm pool keeps on increasing, and you keep assigning the machines one by one. Why do you have to assign every user a machine? Because as I said, this is a 2 CPU, 2 GB machine, that all those resources will be completely used for a video transcoding process. And the same is true for, Replit. If you go to Replit, you get some vCPU, some GB memory, some space over there until your Replit session is closed. So, they need to give you some part of their compute for a long time. So this is one way. What is the problem in this? Number one, you're maintaining a warm pool. You have 20 machines always running, which might remain idle. So, you're playing for 20 machines always. Not a problem at scale. If you have a lot of machines, if you have 1,000 users, then it's fine. You pay for 20 extra machines when you're creating 1,000 machines every month. So the cost isn't anything compared to you paying. If you have throughout the month, you're starting 2,000 machines. Doesn't matter if you have 20 in a warm pool for a long time. It's fine. But that's the first problem. What is the second problem? Resource sharing is also sort of a problem here. You are restricting the user. You will have complete access to 2 CPUs, even if you are not using it. Maybe this 1080 to 1080 takes 100% of the CPU. 1080 to 720 takes 100% of the CPU. But 1080 to 360p does not take a lot of the CPU. So, would be nice if this can be shared. If I can just have 20 CPUs, that can probably be shared by, 30 videos. Because, a lot of times one video reaches the 360p stage. So it does not need as much CPU. So you can't really share compute. You are restricting, every video will have its own set of compute and GB requirements. So, that is the downside of this approach. But still a pretty decent approach to follow in, this third use case of having a Replit-like website or a video transcoder website, have a warm pool and increase the warm pool. What is the other thing you can do? The other thing you can do is an architecture we've discussed a few times. Anytime a video transcode happens, you push it to a queue, and then, you have workers that asynchronously pick this up from a queue. And if this queue length becomes very big is when you scale up your servers. So, if 100 people submit a video upload, then you slowly can scale up. This length has become very big. Let me scale up the number of servers to 10. And then as this length goes down throughout the day, because they will transcode, and as they transcode, this queue will sort of become smaller and smaller. Then you can scale down. So that is another sort of architecture. The problem with this architecture is it works for video upload, because video upload mein YouTube says, after you upload, YouTube says you please wait for 1 hour, video is processing. So, they have that kind of an expectation / SLA with you. This is not true for Replit. When you go to Replit, and that is why, Replit breaks if all of us will try to create Replit at the same time. They cannot have a warm pool of 1,000 people. They usually do not get a spike of 1,000 people. But, if all of us right now go here, then most probably will crash Replit because they don't have such a big warm pool. And they cannot use this queue-based architecture because this is slow. Queue mein you only have 3 workers, let's say, then everyone will pick them, slowly, one by one. Versus, and you can't expect that on Replit. Sorry, wait for the next 30 minutes, we will get computer for you. You cannot tell that to the user. Which is why this queue architecture will not work for Replit. What will work for Replit? The original warm pool architecture or a Kubernetes architecture that I've already discussed in a YouTube video. Let's call it here, guys. Boy, we discussed a little too much. I think I've been speaking for a long time. So let's, do some candid discussions, questions, all that jazz. Is there any other special kind of way to scale applications in some use case? No, these are the 3 I can think of. Generally, the thing that will be asked is this. I guess the fourth thing can be, cricket matches. Because when you have a cricket match, sorry, this is the last thing. Cricket match that's happening in Mumbai. Let's say this is the, India map. It's Mumbai. Then the video transcoding is actually something that doesn't need to scale. A single stream goes from the Mumbai server to some server, in some data center, let's say in Mumbai only. And this sort of converts the incoming stream, which usually is RTMP, over to an HLS stream. The problem that comes is, how do you send this to so many people? So usually the scaling problems we have discussed here is not about sending data. A lot of people will ask a lot of data at the same time. It's more about, a lot of people will be like, give me some, I want to sign up, I want to sign in, I want to do something, or very simple e-commerce website backend route handlers. This is a completely different problem. If you have a cricket match happening, the problem is too many people are asking for 720p video, which is a lot of bandwidth, and India cannot support this much bandwidth. So how do you 720p? A lot of people are asking for 720p video. How do you send this, for all practical purposes, MP4 video, or HLS is a better format that is used for streaming in these websites. How do you? This is the easy bit. Getting an RTMP stream, transcoding it to HLS is the easy bit, and creating 3 qualities out of it is the easy bit. The hard bit is sending it to so many people. How do you scale that? And the answer, surprisingly, over there is also auto scaling groups. In AWS only, there is a video on YouTube where Hotstart discusses this. How do they scale their infrastructure? The answer, surprisingly, was auto scaling groups in AWS. I thought they would have a very elegant / cloud native architecture, but apparently not. They use ASGs, which is something we'll be discussing tomorrow, to scale up infrastructure in case of spikes. All right. With that, let's answer some questions. Clusters in Node.js allows to run multiple instances, whereas worker threads allows to run multiple application threads in a single instance. Yeah, that's what I'm worried about. Okay, it lets you run multiple threads in the same instance. Does that mean Node.js is not multi-threaded anymore? Because you're saying it lets you run multiple threads. Clusters multiple instances. Yeah, can you send me a link of the second thing? Worker threads. So there's the concept of workers in the browser, but I want to understand worker threads on Node.js, if that is a thing. Does cluster worker do all the calculation? Yes. If you look at the code, this calculation is being done on a worker. So if you have 10 small, not worker, like whatever, the child process. If you have 10 child processes that were created, and a request comes to a specific process ID, this thing over here, then this logic is being run on that specific process ID, or that specific process is handling or doing this very expensive computation. Notion. Can you explain horizontal scaling architecture logic again? Yeah, we'll do this tomorrow again, but let me quickly share. Horizontal scaling. I'm assuming your question is what is horizontal scaling, and the answer is fairly simple. If you have a backend application, you want to horizontally scale it, means you want to increase the number of servers that can handle requests. You will usually have a load balancer in front of them. So your user will send a request to a load balancer, and the load balancer, as the name suggests, will forward it to one of these instances. If you feel like the load is going up by a lot, then you can horizontally scale, which means you can add more instances. Or if you're using the cluster module, if you're using a language like Rust that's handling, creating threads to handle all the requests, then you can vertically scale as well. You can increase the size of a machine. Those are the 2 ways to do scaling. Off topic request to, okay, answer that. Seems like I went to the other. Let me start from the bottom. Are we using all the cores by using cluster module? Yes. We are starting 10. It's similar to you starting 10 node index.js processes. So yes, if you start 10 node index.js processes, or if you run node index.js 10 times, then yes, they can theoretically run on all 10 cores of your machine. Do they? As someone said, someone tried and started 10 Node.js processes with infinite while loops. All of them cannot. All of these are very expensive. By expensive, I mean they are completely. Whenever the CPU comes to them, CPU realizes, yaar, ye to mujhe chhodta hi nahi hai. It does not leave me. It keeps on running me again and again. So whenever it interleaves back to Zoom or Google Chrome, is when there might be, the core might be used for something else. But yes, theoretically, if your machine was running no other application, then yes, if you start 10 Node.js processes, or if you use the cluster module, you can use the power of all 10 of those cores. Please revise this. We will tomorrow revise this. Horizontal scaling, though, we will anyway start from the top. But yeah, sure, happy to. The node keeps send requests to the same server because it's a feature in Chrome and other browsers. If both requests come, Chrome wait for the first request to finish and then save the result and pass it on. So avoid Command Shift R. I tried Command Shift R as well. Still did the same thing. And also this happens in Postman. This happens in curl also. So if this was a browser specific thing, why would it happen in curl? Why would it happen in the terminal? If I'm running curl, oh no, it does not happen in curl. So yeah, it's definitely something in the browser and Postman. So yeah, if I send the request from the browser, then the PID changes in every request. It is a browser specific thing. That's what I had guessed only. But yeah, so that you pointed to two Stack Overflow links. Let's look at them. I've created workers 5 seconds to verify. I've opened the multiple tabs. Only one worker is responding. That makes sense. They have a similar problem. And what was the solution? The while if you have some problem, you might be using set timeout here. If you said that being said that the comment is true. Cluster does not do round robin load balancing. So as long as work one is available, difference between F5 and control F5. My best guess is that your browser is keeping a connection to the server alive. That might be it. So that might be it. The browser is keeping a connection alive to the server. How? I don't know. But because after if I tried the same thing after 10 seconds, then it was not a problem. If I stay here for 20 seconds and then refresh, then it was going to another worker. But if I immediately keep refreshing, then it went to the same worker. So it's probably creating a connection somehow to the worker, and then you're not letting go of it for the next 10 seconds, 20 seconds, which is why, the same PID keeps on coming again. If I wait for some time and refresh, then it happens. But if I refresh it again and again here only, then it doesn't happen. So yeah, good find, dude. Should we do $25? Let's do $25 in case you need it. Of bounty for finding the link. Sir, can you show how to implement auto scaling in 1 to 100 projects? Yes, we will. Yes. I mean, we'll understand auto scaling generally tomorrow. We will understand auto scaling groups auto scaling constructs in Kubernetes. And then of course we can add them to, our whatever projects we're creating. How to calculate requests per second for my application without doing a load test? You don't need a load test for that. You just need some basic monitoring. What is monitoring? As the name suggests, monitoring the number of requests. There are multiple ways of doing it. We will cover this in 1 to 100 when we reach New Relic or Grafana. So Google about them. That's one way to monitor the number of requests. But generally, basically, your system is logging all the requests that are coming, and you take those requests and put them in a different system. But Grafana does this, or Prometheus does this in a little more elegant fashion, which is something we'll discuss in 1 to 100. Sir, will you show how to answer that? Can you share the CPU utilization after forking different processes? Yes, you can. Whenever I create whatever I did, and I'm not overloading. If I put like a while loop here, so let me decrease the total CPUs to 3 over here. And let me in this process, rather than creating an app server, let me do an infinite while loop here. Then CTR++. Now if I run this, and if I go to whatever htop, you will see why do I have so many? I thought I decreased it to 3. Worker 1, 2, 3, 4, 5, 6. Okay, a lot of workers started, which is all of these over here. And there is 0 CPU utilization here for some reason. Let's also log. Firstly, let's decrease. Is this in TypeScript? My bad. TSC-B. I forgot to compile it, which is why, as you saw, there were like 10 processes. They were at 0% utilization because, I was not sending the request there. But now let me recompile this code. What is the code again? What is the change that I've made? Whenever the fork happens in the else, which means in the child process, I have an infinite for loop. So it will probably keep running for, infinitely, which means it will be a CPU intensive process. Let's compile the code. Let's run it. primary is running, probably the children bus is running as well. If I do an stop, you will see one Node.js process running at 96, another one running at 96, another one at 96. There are 3 Node.js processes. As I said, it's if you use the cluster module, a new process is what is started, which means you will still see 3 of them over here. It's similar to doing node index.js. The thing that cluster module provides you is you have a single port that can now handle all the incoming requests. So yeah, that's the auto CPU utilization after starting multiple processes. If you of course started normally, with the original code that we had, then as you saw in htop over here, I saw 10 different processes. They had 0 utilization because I'm not sending any requests from the browser to them. So the CPU was at 0%. When will we reach Kubernetes? I structured the syllabus yesterday. I think there is 3 to 4 more weeks before we reach the right side of the syllabus, which includes monitoring and advanced DevOps stuff. So 4 weeks, I would say, which means 1 month. How to answer that? The node keeps send request to same server. Okay, answer that. Sir, will you show how to implement? Answer that. PR को देखते हैं यार. अभी brain is not functioning to be able to review PR. I read storybook. I don't remember, sir. I gave the bounty. I'm sorry, I was not able to review it. I've seen it. I just need to merge it. There's already a bounty I've given, so feel free to get that. But yeah, I'll merge it soon. How do you? Okay, answer. So दिमाग फट सा गया है. Have to record. Yeah, not surprised. We covered a lot of things. Yeah, and also a lot of implementation. All right, one more round of questions, guys. Let's do it. All right. Cluster PID answer. When a new connection is established, it is assigned to one of the worker processes, and the worker process will handle all subsequent requests for that connection until the connection is closed. There's a connection timeout. Suppose in the URL the connection was assigned to one of the workers, which is why it was having the same ID, as long as the connection remains open. What does connection remaining open mean? The problem is, if I open the network tab over here, you will notice, the request ends. So what do you mean when you say connection is open? I read that in the Stack Overflow answer that someone else sent as well. After a certain period of time, the browser closed the connection due to inactivity. So you're saying the HTTP request is somehow active or something else. What do you mean when you say connection? Causing a new connection to establish. That makes sense. What is the other thing? The master process in Node.js, the cluster module creates a master process. The master process is responsible for creating and managing the worker process. Exactly. That's a great way to put it. I probably did not mention this at all. Okay, what is the is primary doing here? What is the master process doing here? All it's doing is creating a bunch of forks. And what is the other thing? Worker processes are actually supposed to, run the thing that's supposed to run on multiple cores and then distribute connections. When a client connects to your Node.js server, the connection is received by the master process, and the master process then distributes it to individual child processes. That's a great sort of, thing to screenshot and more comprehensive way to understand, what happens. All right. I guess you run all freelancing course to Kia Technologies firm. Can you share the importance of starting an agency firm? Why is it better? Yes. For freelancing, the benefit is, it only applies if you earn under, some certain income brackets, which is, if you earn less than 75 lakhs. Number one, if you have a company, be it your, LLC or private limited, get the easiest one. You can, for number one, distribute salaries, which is pretty legal. You can say my mom is my CEO, my sister is my CEO, whatever. Give them titles and, distribute salary. What is that? Why is there a benefit there? There are slabs, income slabs. Whoever is getting less than 10 lakhs doesn't have to pay a lot in taxes. So, you first distribute among 10 members of your family. That's one benefit you have. Other benefit is, which is not really a benefit, but read about it, 44AD and 44ADA. You can't really use them in tech because, you have to show expenses and tech doesn't have any expenses, but people do it. I don't recommend doing it. What I recommend doing is, employees and, distributing money. And CA is probably the best person to answer this. Okay, Notion doc. Yes, forking over here is very similar to forking in C++. Jay Kumar. Browser network tabs are disabled cache. If you enable it, again, different possibility. That makes sense. So yeah, but I still don't understand what. But yeah, so caching makes sense. If you say something is being cached somehow, then I'll be like, sure. But someone said connection remains open. I just want to understand what connection means over here. When will Rust Bootcamp come? Rust Bootcamp will probably come Monday. And Web3 cohort probably a month, guys. In case of Hotstar, serving the same thing 700p multiple users, it is a use case for caching, right? How does ASG help there? Yes, it is a use case for caching. But what is caching? Where do you think caching happens? It happens on machines, right? What is a cache? If there are multiple people in Punjab, you want to make sure all the people in Punjab get the data from the machine in Punjab. If multiple people are in Rajasthan, you want कि जो तुम्हारा source है, your source in Mumbai sends video to a machine in Gujarat, and then everyone in Gujarat gets it from the same thing, right? So you do have to cache, and a lot of times you don't need caching, you need CDNs, which are content delivery networks, which pretty much do what you're saying. They cache files. But yeah, go through the video, covers it in detail. It's on YouTube. Just search for Hotstar architecture video. You'll see that it's like a big guy explaining how they do what they do. Once so that I'm not in Thailand. Why is that? There are multiple South Asian countries that can have the same time zone. How much full stack should you know for Web3? It's a good question. It's something I'm also trying to figure out an answer. Do we need to have some flavor of full stack in Web3? Because most projects are full stack only. Other than writing the contract, you do a bunch of full stack stuff. So answer is yes. I mean, what you've done in the code is more than enough. Basically, you don't need anything more than that. In full stack, we might have a small mini, full stack bootcamp in Web3 as well. Because yeah, which one is better, PM2 or the code one? What is the code one? One PM2 or code one? What does code one mean? This PM2, this is PM2. Are there two different PM2s? I have no idea. I don't use no one use PM2. Yeah, we just use it right now because you have a single server, but eventually you containerize your applications and you just start a Docker container in restart mode. So if it drops, it restarts. Yeah. So it doesn't matter which one's better. You use anyone for now, but eventually you won't be using them. What if we have an auto scaling? Then what will happen if someone DDoSes the website? Considering we didn't have DDoS protection, your servers will blow up. Yes, your servers will increase, right? So you of course have a max limit in auto scaling. You have a min and a max. When you auto scale, you have a min and a max. Can I at max have 50 machines? So if someone DDoSes, you will start 50 machines, and that's what you will pay for it. If we drain users, then packets will lose. Users are disconnected from the connection. They might see lag. Yes, if you drain users, which you avoid as much as possible in a WebSocket connection. But yes, if you do that, there will be a lag of some messages being missed, and you will need to refetch the messages when the connection of the user changes. If YouTube is in YouTube, suppose I upload a video quality to 1080p, will YouTube transcoding also convert it to 1080p, or will I try to figure out the maximum quality and transcode? It will most probably, I don't know actually how YouTube does it. I would assume they still convert your 1080p into another 1080p version, because their 1080p version might have optimizations, a lot of compression that is good for, because you might just upload 100 GB video. If you upload 100 GB video, doesn't mean all the end users, when they're in 1080p mode, they should also not see 100 GB video, right? So it will compress it, the data. So it will. Answer is yes. It does recreate the 1080p variant. All scaling and maintaining a warm pool, all the scaling on a warm pool, do we code this, or is it more like turning on some service, it will handle it on? Great question. So there are GUIs for this. Tomorrow we'll understand the GUI. There are CLIs for this. There are Node.js libraries for this. So you can do pretty much all of this, using any way you want. You can do it from a GUI. You of course don't want to do it from a GUI. You want, what did we discuss? We discussed, there will be a process that will be listening to the aggregated values. There will be a process that will be listening to aggregated values and telling the auto scaling group, please scale down to 10 machines. Please scale up to 20 machines. So, there needs to be a Node.js library that can talk to an auto scaling group. So yeah, seen this. I couldn't do because of slow laptop. Decrease the number of CPUs to 2 and then try it. Alright, answered. Alrighty. Cool, guys. Should we call it? Or should we do one more round? Let's do one more. And then we'll call it. there is a keep alive header in the browser. It takes some interval, but there is nothing present curl. Yeah, find the exact answer. Let me know. Probably is that. Could be the keep live header. I don't know. Probably. Yeah. I have a few doubts. The thread. Please check this thing. Oh my god. You naughty boy. Akhil. I mean, I'm not connected to a VPN. So you would have found out where I was. But no, you will not. I was able to read it in the title. So felt very fishy. First time I'm seeing like dub.sh link, so like that seems fishy. What he sent was an IP, the thing that would view my IP to everyone. But sorry, sir. If you're smart, I'm smarter. If you are bad, I am your dad. If the crypto course launches in May and it takes 5 months to end, wouldn't the crypto bull run end by then? I mean, yeah, I trust me, I cannot predict this. No one can predict this. If I were to say yes, we might end, might be on the bullish of the bulls. We don't know. Node cluster, only one process being used. Yeah, I saw this as well in the morning. And this is answer pretty much gets us nowhere. Yeah. What if someone sends malicious code to the video? What does YouTube? I mean, I'm sure they have a bunch of checks to make sure that the video format is like a very common attack vector. Whenever you're getting files from an end user, be it images or video, you do a bunch of security checks. If some thread or other process is running in the back for handling asynchronous tasks, then the process or thread blocked. Then how does Node.js claim to be non-blocking? The JavaScript thread is non-blocking. The JavaScript thread can still run. There is an asynchronous thing that is being handled by someone else. There is a file request that might be happening. File read that might be happening. There might be a fetch call that might be going out. There might be a database call that might be going out. But the thread is still busy doing its thing, right? Moving to various code segments and executing. The thread is non-blocking. What does non-blocking mean? Whenever you reach a code that looks something like this, const x equal to await some function, you are not blocked over here. The thread will go and do its thing and eventually come back here whenever this await, which is just await is nothing, it's just syntactic show for promise. So whenever this promise resolves, it will just come back here. Merchant app on the stack is all I will say. It will happen. When is the question? How does the cluster exit? Process.exit stop the process. Why is that a question? How does the cluster exit works? Or if you stop the process, it stops all the children. I guess that's a question. It will stop all the processes. How can two different cloud providers come into picture? Oh, well, for example, in case of a cricket match, one cloud provider is not enough. So you will have deals with multiple CDNs, content delivery networks, and some of them will have servers in Rajasthan, some of them will have servers in Gujarat, and then whenever the peak spike of IPL happens is when you will turn on all cloud providers and be like, bro, everyone please serve the right traffic. If the crypto course launch, okay, answer that. Can you show the calculation for an SLA? Calculation for the SLA. For which SLA? For example, one basic paper math was the most basic paper math it was okay, our server can handle 100 requests per second and our system has 1 million users. Each user sends 100 requests or 1000 requests in a day. So I did what? I did number of users into number of requests in a day divided by 3600 into 24, which is the number of requests per second. That is the number of requests per second we have. A single server can handle 100. So how many servers do I need? This number, whatever this number is, divided by 100. These are the number of servers that I need to handle this. What's your second question? Sorry if I already answered this, but can chess game be made by HTTP server rather than WebSocket? For most practical purposes, yes. But there is one thing for which you cannot use HTTP. The thing with chess is you don't send a lot of data. So there are two benefits of WebSockets. One, whenever you're sending a lot of data, you should use WebSockets, so you don't have to do the 3-way handshake every time an HTTP request is sent. So that's one benefit. Chess you don't play a move as often, so it's fine. The other problem that there is always server-side events. You have to push events from the server. If one person makes a move, it needs to be pushed to the other side. HTTP cannot do that. You cannot push something via HTTP. So this guy either needs to keep polling, has the move been made, which is bad. Good thing is WebSocket. So you can make whatever you can make in WebSocket, you can make in HTTP by polling, but you shouldn't do that. Yeah, I want the Mountain not responding to my message. I will not. Please ping Ankur or Rookie. They will do it. End of month is here is when money gets spent. So should have it by 31st, maybe like 2nd, 3rd also. There are a lot of people like small, big Mounties, but yeah, if it's less than $100, Aryan is the one who's clearing it. What are the best operating system? Open source blockchain, especially related to fintech. All fintech, all DeFi protocols, Uniswap, Drift protocol have their contracts open source. Maybe not their code open source, but most of them have their contracts open sourse. You can look at them. All right, thank you. Notion doc is not open. Another Notion doc by Rohan Vaidya and one by Abhay Gupta. So last two things, guys, and I'll call it. Is my internet bad? Well, you're out of luck. Let's try. Either Notion is down or my internet is. And it is Notion. Yeah. Oh, there you go. Let's see. Sorry, guys. Oh, no. Oops. Did not reload. This one's still loading. We'll have to call it here, guys. Sorry. These two Notion blocks got missed. Create a thread. If they're super important, create a thread and tag me there. I'll pick it up from there soon enough. Let's call it here, guys. Good class. I'll see you guys tomorrow. We'll be implementing some auto scaling groups in AWS. Maybe doing a bunch of other AWS things. Good night, G.